Clean energy, sustainable energy. That's what we are looking for. Clean means basically it's not emitting greenhouse gases, methane, N2O, and of course CO2 and so on. And we said indeed there are such sources, and when we ended the last podcast we said even the fossil fuels are ultimately solar energy because the plants use sun's energy to do the photosynthesis and put all that hydrocarbon photosynthesized material into the ground. So candidate 1 on renewable energy is the sun. And the most sustainable source of energy, of course, says the sun. In 1 second I give off as much energy as all of you combined consume in 760,000 years. So if you take amount of energy we are producing every year across the world and see how much how much energy is coming from the sun every second, then if we could capture all that energy from the sun that comes in just 1 second, then we could run ourselves for 760,000 years. In other words, it's a very long time. This problem would be CO2 problem, greenhouse gas problem would be solved if we could capture even a small bit of that energy. But yes, the earth is quite a long way off, so only a little bit of my energy ends up in the crazy planet of yours. Sun is producing some energy and we are far away, so how much energy does really come to us? Right? So imagine that there is a stove in a room in the kitchen, let's say, and the stove is getting warmer, and if you go close to the fire and the stove you feel the heat, but if you move away towards the walls, let's say away from the stove, you don't feel it anymore, right? That's what we are doing here. Imagine that you could capture all of the energy. If you could, then an hour of it would still be enough to power all 7 or now we are 8 billion and all the cars we are running, all the phones and computers and video games, and of course all the factories as well, for 1 whole year. In 1 hour on earth we are getting enough power. So in the beginning here we said just sun at the surface of the sun is producing so much energy in 1 second that it's 760,000 years of energy that we consume, but on earth much less is coming in, and even then an hour of the energy on earth is enough to power everything for 1 year. So I can see why you are building solar power stations everywhere and installing solar panels to convert my light into electricity. The biggest of these solar power stations is in the United States, but this keeps changing, so you have to look at the latest one. No, wait a minute, actually it's in China. No, in India. Hang on, how about you go back up, you go look it up. Hang on, how about you go look it up yourself. Every few months a new solar power station comes along that's even bigger than the last biggest solar power station. So whenever you listen to this podcast, you go on Google and you say, what is the biggest solar production place in the world, solar power station in the world? And I'm not talking about fields full of solar panels like you can see in the various places in the United States and Canada. No, it's about real power stations where electricity is generated by heating water. You're pretty smart with your water towers and your hundreds of thousands of mirrors all around. You can be boiling water. The mirrors turn automatically to follow me and reflect my light to the tower. So you put some machine that is smart so that as the sun rises and moves across the sky to the west, this mirror follows the sun and beams that energy to somewhere where you can heat water. That's called solar thermal. So here is some water, here a bunch of mirrors that are taking sun's energy and beaming it towards the water tower and heating the water. What do you do with hot water? Of course, as you boil water, it becomes water vapor and puts a lot of pressure. Remember, this is what we did for our old steam engine, right? You produce water vapor, it puts pressure, you use the pressure to do the work, right? Solar panels are of course another option, but the temperature gets so high that steam develops when you use these mirrors and beam it onto a tank, and this can power a turbine just like a typical power station. The turbine turns and there is some dynamo effects that produce electricity, which you probably learned somewhere. If you don't understand, don't worry about it. But if solar panel is there, then it works differently. Solar panels are made up of rows of solar cells. The solar cells contain two layers of silicon. Basically like sand, it's converted into this material called silicon, a substance that is also in sand, so we can get silicon from sand. When I shine on when sun says, when I shine on the solar cell, a small current runs between the two layers, and that current can get electricity out of that current is basically the electricity we're getting out of sunlight. It doesn't go entirely smoothly though. Most solar panels convert less than 20% of my light into energy, but if you guys keep working away at it, then you will make new panels that are better and better. This is the efficiency, right? If you eat something, you want as much energy as you can get out of it and not eat junk food so that you feel full but you don't get much energy out of it. It's the same way right now we are building solar panels that are able to convert sun's light into electricity, but they are only doing 20% of the solar light into electricity. So efficiency is low. All in all, I'm a fabulous candidate for sustainable energy, even if I do say so myself. Okay, CO2, I'm fumbling the words a little bit, so listen carefully. I'm hungry actually. It's lunchtime, children. Okay, so CO2 is released during the manufacture of solar panels and the construction of power stations like this, but not after that. I'm also not going to run out of power for the next few billion years, so sure, you are kind of dependent on the weather. When it's cloudy, solar panels don't produce as much electricity because we don't have direct bright sunlight, and when it's super sunny, you don't know what to do with all of that electricity because you may be producing too much. So you need a battery to store that solar energy for those times when I'm not shining. Not a little battery, but a big one. Imagine a solar power plant that's producing so much energy that you cannot use immediately, but you can put it into a battery and use it at night when the sun is not shining, or when it's cloudy and sun is not producing as much energy for us through the solar cells. So what's that? Far too expensive and complicated? There is always a catch when we look for electricity or energy or renewable and so on. So here is Helios, the Greek sun god, and Ra, the Egyptian sun god, and this goes into the next page where we look at Helios again, and we look at Hawaii, Aloha, which has a lot of sunny days, Ra, the Egyptian sun god, and here are people using sunlight to tan themselves, and then it says, you are blocking my sun, to somebody who comes in the way, let's say like this sun god putting a shadow on this lady who's trying to get some tan. And here is Teotihuacan, Mexican pyramid of the sun. So people have known about sun's energy for long, and now people are putting solar panels on the roof so that you are happily living inside, but you are getting some energy from the sun. And of course, the sunflower has always known to follow the sun. It blooms and then it follows the sun. It actually has muscles to turn itself, and it has optical sensors. It can see light and say light is moving, so it can use the muscles to change direction. Stunning, isn't it? And here is a camel which lives in the desert and can get a lot of sun power, sunlight and solar power every day. We'll come back and talk about the winds, as we said. Winds are also solar power because sun's energy is distributed in a way that there is excess energy in the low latitudes and lack of energy or deficit energy in high latitudes. And if we want high latitudes to remain at steady temperatures and not get colder and colder because they are losing more energy than they are receiving, then they have to get energy from somewhere else, not from the sun, and that comes from winds from low latitudes, because low latitudes are receiving more energy than they are sending back to space, and they are sending a lot of energy to higher latitudes. Right? We talked about this before when we talked about energy balance. So we'll come back and talk about how wind can give us energy. And now I will go and eat so that I don't fumble the words and you think, what is this guy talking about? Grandpa is falling asleep. Okay? See you in the next podcast about talking about wind energy. Okay?